Okay, and our last set of these are slightly more complicated. So you can see now we've got cos 5x equals 0.482, and our final x values have to be between 0 and 72. So let's start it the same way. Inverse cos of 0.482 gives us 61.2. It's cos and it's positive, so it's in there. So draw our diagram and mark on our 61.2 degrees in our first and our fourth quadrants then. So now we'll look at our range. Our range for x is between 0 and 72. So if we multiply that by 5, well 5 noughts are not, 5 72s are 360. So the range for 5x is from 0 to 360, so we're going to go the whole way round. So round to our first line, we get our 61.2, so that's 5x. So divide that by 5 and you will get 1x. Then round to our second line, that will be 360 take away 61.2, so that gives us 298.8. That's 5x, and then divide it by 5 and we get 59.8. Do a quick check to make sure our x values, our final answers, are between 0 and 72, and they are, so we can be fairly sure that we're right. And our last one, tan of 3x minus 10 equals minus 3 for x between minus 60 and plus 60. Again, let's start it in the same way. Inverse tan of 3 is going to give us 71.6. It's tan and it's minus, so these are the two quadrants we're looking for. So draw in your 71.6 in either of them. So now we'll look at the range. So that's our range for x. So our range for 3x, which is what we have, multiply these by 3 and we get us from minus 180 to plus 180. So that's where we're going round the two different ways. So if we go round in the positive direction, this angle here would be 180 take away 71.6, which is 108.4. That's what 3x minus 10 is. Now we have to solve this equation to give us x. So the first thing we do is bring the minus 10 over and it becomes plus 10. And then we divide by 3 and we get 39.5 degrees. Then now when we're going the other direction, we get that this angle would be minus 71.6. And again we solve, so 3x equals minus 61.6, and then divide by 3 and we get minus 20.5. Check that our final answers lie between minus 60 and 60, both do, so again we can be fairly sure that we're right.